This question is from the chemistry chapter chemical kinetics. In this question, the rate constant for a decomposition of N2O5 at various temperature is given by this table. We have to draw the graph of lnk and 1 by t and calculate the value of A and EA. And we have to predict the rate constant at 30 degree and 50 degree Celsius. So to solve this question, we are going to use the Arrhenius formula. So based on the Arrhenius formula, K is equal to A e to the power minus EA divided by RT. So we are going to use this relation to solve this problem. So if we apply the ln on the both side, it can be written as ln K is equal to ln A minus EA divided by RT. If we assume that this is your Y, this is your C, and here is the M into X. It means that if we arrange it properly, it can be written as now you see this is completely your Y, and now this is the M. This is completely M means the slope, and here it is the X, and this is the constant. So based on this, we can say that slope is equal to minus EA by R, and this slope is negative. And now second thing, we know that Y is equal to mx plus c. This Y is equal to mx plus c is the equation of a straight line. So if we have to draw the graph of ln k and 1 by t, so we can draw it. This is our 1 by t, and here it is ln k. So the graph will be a straight line, but it will be negative slope. So here this is the graph of the ln k and 1 by 2. So this is the answer for the first part of the question. In the second part, we have to find the value of A is the Arrhenius factor, and EA. EA is the activation energy. So let's find it now. So we know that slope is equal to minus EA by R, and slope is nothing but dy by dx. Based on this graph, dy is our ln k and dx is 1 by t. So this can be written as ln k divided by 1 by t. So in the table, k value is given. This is the k values, and this is the temperature. So based on that, if we have consider any two references means let's consider these two values here. So this we can consider as K2, and this is K1, and these two temperature, this is the T1 and this is the T2. So in the relation, if we have to find the slope, we have to write the ln k by 1 by t. So we need to convert these to K1 and K2 in term of ln k and this temperature in the reciprocal form. So let's first do that part. So we can write it here. T1 is equal to 0 degree Celsius. It's equal to 273 Kelvin. So 1 by T1 is equal to 1 by 273 Kelvin. Its value will be 0.00366. Same thing, T2 is equal to 20 degrees Celsius. In Kelvin, 293 Kelvin. So 1 by T2 is equal to 1 by 293 Kelvin. It's equal to 0.00341 Kelvin. So we got the value of 1 by T1 and 1 by T2. Similarly, we need to find the value of ln K1 and ln K2. So K1 is equal to 0.0785 into 10 to the power 5. Here is the 10 to the power 5. So ln k1 will be equal to ln of 7870. It is equal to 8.97. Similarly, ln k2 will be equal to 1700 and its value is 12.04. So now we got the value of ln k1 and ln k2. Similarly, 1 by t1 and 1 by t2. Now we have to find the slope. So we substitute the value of ln k by 1 by t. So this is equal to change in the slope. So ln k2 minus ln k1 divided by 1 by t2 minus 1 by t1. So slope is equal to 12.04 minus 8.97 divided by 0.0034 minus 0.0036. Here we can write 1 and 6 extra. Now if we further solve it, it will come around minus 12298.8. So we got the slope value, and in the question we have to find the value of A and the value of EA. So let's solve it based on this information. So we know that slope is equal to minus EA by R, and slope we already found it here. So if we substitute this slope relation, can we find the value of EA? It means that if our minus EA by R is equal to slope, and slope is equal to minus 12298.8, so based on that, EA is equal to 12298.8 into 8.314. So based on it, EA is equal to 102.25 kilojoule per mole. So we got the value of EA. Now we have to find the value of A. So to find this value of A, we have to use either this relation or this relation and substitute the value of any of the table that we already found the value of ln k1 and ln k2. Any one we can take. So based on this, we can substitute the value of ln k and the temperature, and we can find the answer. Ln k, we can take the ln k2 value. It's equal to 12.04 is equal to ln a minus EA is, this is the value of EA. So we substitute it here, 102250 divided by gas constant is 8.314. Temperature for K2 is 20 degrees Celsius. So it's 293. So ln A is equal to 12.04 plus 41.97. So ln A is equal to 54.01. So A is equal to the exponent of 54.01. So A is equal to 4.06 into 10 to the power 23 second inverse. So this is the answer for the A value.